Today we're going to learn about algebraic expressions. Okay, you're going to have some vocabulary for this lesson. First thing you need to know, what are terms? Terms are the parts of an algebraic expression. Like terms are terms with the same variable raised to the same exponent. In simplest form, when we're talking about algebraic expressions, is when an algebraic expression has no like terms and no parentheses. Everything is combined. And we're going to talk about these. So this here is an expression. Now, what I said were terms are the individual parts. So 19x squared is a term, 6x is a term, 2x is a term, and 7 is a term. These are the parts. Now, like terms are the ones that have the same variable raised to the same power. In this expression, 6x and 2x are like terms. They both have the same variable x raised to the same power, which x, just one x, is x to the first. So these two are like terms. If we wanted to put it in simplest form, we would combine these like terms so that we have no like terms and there are no parentheses in the first place. Okay, so the first example, we're just going to identify the like terms. So if we look here, we're going to first rewrite as sums of the terms. And all that means is we're just going to keep change everything that's subtraction and make everything addition, or rewriting as sums of terms. So we're going to change this minus to a plus. That'll be a negative 2. And this minus x will become plus a negative x. So now our terms are 9x, negative 2, 7, and negative x. So we're going to look at the like terms. Now we see that we have 9x, and then another, and this raised to the first power, and we have another x raised to the first power over here. So 9x and negative x are like terms. Constants, meaning just a number, can also be like terms. So negative 2 and 7 are our like terms. So if we write it out, we have 9x and a negative x, and negative 2 and 7. Let's look at another example where we're going to identify the like terms. First thing we have to do is we got to rewrite as sums of terms. We're going to keep change everything that we need. So if you look here, only thing we had to change was this minus, but this minus 3z squared becomes a plus a negative 3z squared. If you look here, this is z squared. We also have another z squared in our problem, and that's a negative 3z squared. Same variable, same exponent. Those two are like terms. We also have 5z and z. They both have z's, and they're both raised to the first power. So they're like terms. We write it out, z squared and negative 3z squared are like terms, as well as 5z and z. Example number 3. Now that we know how to find our like terms, we're going to simplify the algebraic expression and combine everything. Just like we did the last time, we're going to have to make everything as a sum. So we had to change minus 1 half y to plus a negative 1 half y, and minus 6 to plus a negative 6. We're now going to combine all of our like terms together, meaning we're going to add them together to simplify this expression. So if we look here, here are our like terms. So we would have to add these together. So whenever we add them together, it'll be whatever 3/4 plus a negative 1 half is, and then you bring your y down. The y stays. Then you also have 12 and a negative 6 that you add together. So once again, we're going to add these two together and add these two together to get our simplified expression. 3/4 plus negative 1 half is going to give you 1/4, and that'll be 1/4 y. Keep your term. plus 12 plus a negative 6 is 6, and this is as simplified as we can get. This expression has no like terms and has no parentheses. Example number 4. We are going to first have to change everything to sums, so that becomes a plus a negative 3z. Now we're going to combine all of our like terms. We're going to add all of our like terms together. So let's find our like terms. Here we have our constants, 14 and 8. We'll add them together. Then we have a negative 3z and z, which are also like terms, and we add those together. Now if you notice, I just brought these up to the front, where the front of the expression is going to be. And that's because we always want the highest power to be in the front. So if we had squared, z squared, that would go first, then z, then our constants. We keep in order from like highest to lowest. So here z is going to be our highest variable, which is our only variable, so it's going to go to the front. So you're going to add those together, and then when you add 14 and 8 together, it also goes into the expression. So negative 3z plus z is going to give us a negative 2, and we bring down our z. Then 14 plus 8 is 22, and that is our answer. Okay. Now, what happens when you have the distributive property? You're going to have to first do the distributive property before you can do the other steps that we did. So we're going to have to say 3 times q is 3q, and then 3 times 1 is 3. So it's going to be 3q plus 3, and then you just bring over your minus 4. You may need to review the distributive property before you do this. We're going to rewrite as the sum, and now we're ready to combine all of our terms. We only have one 3q, so it'll go down by itself, but then you have your constants 3 and then negative 4, which are your like terms. Bring them down. 3q will go in the front, and then 3 plus a negative 4 is negative 1. If we wanted to rewrite this where it looks cleaner, because that plus negative 1 is kind of clumped together, you can rewrite it back into a subtraction problem. 3q minus 1. Okay, try these on your own. See what you can do.